everybody who is watching this video. I'm Sir Olenjolai Yailo Singo from the beautiful country known as United Republic of Tanzania. I would like to welcome you into these fantastic sessions of gravitations are the ones of the topic of mechanics. Before I start my sessions, I would like to give a very brief introductions about the channel. The main vision for this channel is just teaching A-level students about advanced physics, advanced chemistry, advanced mathematics, and even basic applied mathematics. So we'll get all of them at this moment. Okay. So again, the problem I'm solving nationally is it happens. Many students used to fear, used even to prefer artistry rather than science because of the difficultness of physics and the chemistry and at A-level stage. Okay. So it means that I'll be teaching you, I will be using the digital technology and even record the live class and solve many questions, use different tricks, encouraging you, give the leadership mindset, and actually transform you to think differently as a person who has a responsibility to solve a particular problems in your community. Okay, so for you to get connected into this or to get connected into this channel, I would like just to give you some few points that you have or steps that you have to follow in order for you to be well informed at any time, because I'll be adding videos. I've prepared myself intensively to do this business and to help you as well as I can. Okay, so in order for you to get connected to this channel, number one, you should have electronic device, because it's digital technology, you deliver digitally. We record digitally, and then we'll use the internet to send the knowledge elsewhere in the whole world, and especially also in the whole country of the United Republic of Tanzania. So number two, you should have an email. If you don't have an email, just go online there in the Google and search that how you can have an email. You can have even 3 emails. That's how. So the space of emails is not limited. You can have the Gmail or Yahoo Mail. It depends to your requirements. And then so if you have your email, that we go to steady state. Go to the YouTube, and then in search sections, write this YouTube channel called Tanzania Online A-Level Secondary Schools, in square bracket, write Olenjolai, right? So that's what you have to make sure that you do, and then in order to be together. So when you get into these channels, you see buttons that has a ready background, and then the white text which is written subscribe, right? So if you're using the mobile phone, then you have to click it once. If you're using the computer, you have to click it once. When you click in the computer, then disappear, and then you see the bell, right? So click that bell and choose the options of all. So now you will be given a special notifications by the YouTube community at any instant that I add a video into this channel. And thank you very much for doing that. You won't spend much time. It's just an exercise of 2 minutes or 3 minutes. Okay. So if that's the case, now let us go to business. This is the departments is advanced physics. Okay, this is the departments in this school. The subject is advanced physics. The main topic we're teaching you today is mechanics, and then the 6th topic of mechanics is called gravitation or gravitational motion. The class, this material is for Form 5 A-level students, and I'll be using the syllabus of United Republic of Tanzania. Remember that, and also for the diploma students who are pursuing engineering. In case that you want to offer your Thanksgiving offering, you can offer through this phone number, right? And then the name is Olenjolai here. So this is the session 3 or the set periods or the lecture 3. I'm going to teach you about applications of Newton's universal gravitational law. So just a quick review that in lecture 2, quick review of what we cover in lecture 2. Make sure that you go, this lecture I prepared them from, I have designed this topic from top to bottom, right? So it's not just like something that I'm roaming around. So it means I'll be starting from the simplest or introductory concept to the end of the topic. So don't watch lecture 3 or session 3 while you didn't watch lecture 1 and lecture 2. So you have to make sure that you watch them. So the quick review of lecture 2, right? In lecture 2, we learned that mainly the main concept, we learned the main 3 concepts. Okay, the first one is Sir Newton's universal gravitational law. We stated it, and then we had the mathematical equation. Also, we discussed a lot, spend much time on it, about universal gravitational constant. This we call the universal gravitational constant, which is labeled as G, okay? And then we discussed about centripetal force, and force of attractions. Okay, that's what we discussed. Again, I told you how can we use the said, or how do we show that the said Kepler's law is consistent to the Newton universal gravitational law. So today I want to teach you some of the applications of Newton universal gravitational law. So just to remind you, we stated that the Newton's universal gravitational laws that we said, it states that everybody or every particle, okay? So everybody or every particle attracts each body, right? So everybody, or let's say just instead, everybody in the universe attracts every other body with a force which is very proportional to the product of the air masses and inversely proportional to the square of the mean distance between air centers. So mathematically, we define that the force of attractions is equal to gravitational constant times mass of the first particle, and then times mass of the second particle, then over radius over square of the air distance between the centers. That's what this is the mathematical equations of 40 of Sir Isaac Newton. So we say that there are many applications. Okay, this is serious class. You have to make sure to take all the resources and you concentrate. There are many applications of 40 of the Newton's universal gravitational law, right? In gravitation. So we have many applications in gravitation. Okay, so some of them, we say that some of the applications are this. So I will be explaining each one after the other one. So it means that in one of the applications, Newton's universal gravitational law is used to determine the mass, okay? The mass of the S. I left your homework in lecture 2. Did you do it? Of 40 of the S. Did you do? So if you did it, we'll do correction. If you didn't do, make sure that you do it before you watch the correction. Okay, to determine the mass of the S. It's a little bit shocking to know that we can use physics and determine the mass of the S. You know, it's a little bit challenging if you take a fraction, maybe some few seconds to think about that. How did they measure the S, which containing cars, people? It's a little bit challenge, but it has been confirmed that it is a true mass of 40 of the S. So how do we use the Newton gravitational law to determine the mass of the S? So we say that we have to make a phrase. We say that I mean that we can use Newton's law. So this is the phrase that we have to make. We can use the Newton's universal gravitational law and the value of acceleration gravity G, right, to determine what? Determine the mass of the S. Determine the mass of the S. How? So that's the question now. Okay? And the questions, it can be asked like this one, that determine or derive the formula of determining the mass of the S and use it to determine the mass of the S. So the questions might be like this. So let us solve. Physics is beautiful. I love it. And I will be convincing you day after day or lecture after lecture, session after session to love it. Okay, in order to answer that question, we have to consider that we say that we have to follow different steps. The first step, we say that consider a body, such as maybe a planet, a communication planet, right? A body of mass m, let's say, revolving around what? The S, right? The S, okay, in its orbit. For instance, the satellite, right? So you say that this is the cycle, okay? So the circle orbit, and here this is the S. So this is the S. Then the S has this mass which is ma, and then suppose that the body of mass m is here orbiting the S, right? The body of mass m, okay? The body of mass m, okay? So the body of mass m revolving around the S in its own orbit. So this is the body of mass m revolving in this circular orbit. So what do we experience there? First of all, we have a distance, we call it in physics in radius of the S. Okay? So radius of the S. So we have mass of the S, we have radius of the S. So the and this is called in orbit of the body of mass m. Okay? So this is the way that or the first step we have to start with. Are you ready to join me on determining the mass or deriving the formula of mass of the S and determining it? Okay, if you are ready, let us continue with the business. The second step now, we said that we call the mathematical formula of Newton's gravitational or universal gravitational law. Universal gravitational law, right? So the formula I taught you in lecture 2 that force of attraction between two bodies is equal to universal gravitational constant times mass of the body 1 of the first body and mass of the second body that are attracting each other, okay, attracting each other with the forces that act in opposite direction. So this is the formula or the mathematical formula of Newton universal gravitational law. And then now, if you apply according to our system here, okay, whereby maybe this I say that suppose that this is the planet that is revolving around the S. So we say that now the force of attraction between the body that is revolving the S will be equal to the universal gravitational constant times mass of the body times mass of the S, right? Mass of 40 of the S, then divided by the radius of the S squared. This is force of 40 of attraction. Okay? So this one we call it equation 1. Okay? Equation 1. So again we go for the third step. The third step that consider the weight of the body in the surface or on the surface. On the surface on the surface of 40, on the surface of the S. So the weight of the body, that suppose that this is an orbit, right? And here we have a body of mass M, and here we have the S that revolving the S in its particular orbit. So this is the S. Here we have mass of 40, mass of the S, and then here we have what the radius of the S. So it means that also when this body is revolving around the S, because it's on the S surface, it has weight that is given as M times 40 gravity, right? So for this case, this mass M, this weight of the body for this case is acting downward, right? While there's a force of 40 of attraction between the body of mass M and T and the S. So, and in that case, in case that this body of mass M continue revolving around the S in its own particular orbit, then we say that, and in that case, we say that the weight of the body balances with the force of attraction, right? Yeah, so it means that we say if the body of mass M, okay, revolves around the S in its particular orbit, So we say that then the weight of the body is equal to force of attraction. So then this is what the second equation. So we go for the force state. The force state now, there's a close relationship between the second equation and the first equation. What a close relationship. Force of attraction is equal to this numerator over denominator, force of attraction is equal to the weight. So if that's the case, you say that we have to equate what? Equation 1 and what? And equation 2. So if you equate them, what do we get? We get mass times gravity is equal to what? Mass of the body times gravitational constant, mass of the S, over radius of the S, which is constant. It's constant and it's known. So now we say that we cancel mass of the body, and then we say that we have gravity times radius of the S square is equal to gravitational constant times mass of the S. What's our intentions? We want to determine mass of 40, mass of the S. So we have divided by gravitational constant to both sides. Okay? So after dividing with the universal gravitational constant to both sides, so now we have a formula or a mathematical equation of determining the mass of the S. So we say the mass of the S now, and in this case, is equal to acceleration gravity, g radius of the S square, divided by what? Universal gravitational constant. So this formula is important. So we say that whereby MA, this is equal to the mass of 40, mass of the S. Mass of the S. And then this is universal gravitational constant. RE, this we call to radius of the S. Radius of the S. So now we can go that determination of what? Mass of the S. We derived the formula, mass of the S. Now we have to find its value. Mass of the Earth. Mass of the S. So he said that from this formula, we just recall. If we recall this one, we call this formula that mass of the S is equal to, remember that some of the books they use mass of the S just like capital M and subscript of 4 capital E. So don't get confused. Okay? So mass of the S is equal to what? Is equal to gravity times radius of the S square of what? Over gravitational constant. Or sometimes, in some of the books, you may find that mass of the S, or even this M it is lowercase, then you say mass of the S is equal to what? Is equal to gravitational constant, then capital radius of what? Radius of the S square of what? Over gravitational constant. So both of these formula are similar. So whether you use this one or whether you use the one that I showed you there, right? So it's just a matter of lowercase and uppercase. So he said that in order to determine the mass of the S, in order to determine the mass of the S, we say that then the values of the constants, have to be given. So what values of the constant we should be given to determine the mass of the S? The value of acceleration gravity, the value of radius of the S, and the value of the universal gravitational constant. Yesterday I taught you how to use your scientific calculator. Now in lecture 2 I taught you how to use the scientific calculator to determine, we say that this is constant. So you write constant, set a 9. So this will give you the value 40 of G. G is equal to 60.67 exponent negative 11 Newton kilogram per kilogram, then meter square. That's the gravitational constant. But against G, we may use G as 9.8 meter per second square. Radius of the S, this is given, right? Will be given. Okay, radius of the S, which is equal to radius of the S as a capital. This is given as what? 6.4 exponent 6 meter. So now to find the mass of the S, this is equal to gravitational constant 9.8 meter per second square, multiply by what? Multiply by the radius of the S, which is 6, say that 6.4 exponent 6, and this is square, and then have meter square, right? And then we divide by universal gravitational constant value, which is 6.67 times 10 power negative 11, and then this is Newton kilogram square, and then meter square. So here we have meter square cancel. Then again that here we have, okay, newtons, we define newtons, what does it mean? And then we cannot simplify with anything else because we didn't define the unit for Newton. So in case of units, then so you can use your scientific calculator in determining the mass of the S. Let me write here because I want to show you how do we cancel the units, because are very important. If you find the mass of the S and then forget the units, that is meaningless in physics. So mass of the S, say that this is 9.8 meter per second square. We multiply with 6.4 exponent 6 square. We have cancelled this meter square, and then in the denominator we have 6 universal gravitational constant 6.67 exponent negative 11. In scientific calculator you'll find even 3, it is fine. Even if you introduce, it's fine. So here we have Newton, and then the base is 30 per kilogram. So remember that Newton is the SI unit of force, right? So if that's the case, if you recall from the Newton's law, where I told you also from from second Newton's law, we say that the force is equal to mass times acceleration. So mass, the SI unit of mass, it is kilogram. The SI unit of acceleration, it is meter per second square, and this is equal to 1 Newton. So we say that 1 Newton is equal to 1 kilogram per meter, 1 kilogram meter per second square. So then we say that now mass of the S will be 9.8 meter per second square times 60.4 exponent 6, and then this square or squared, and there we have what is 6.673 exponent negative 11. Now instead of newtons, we replace with kilogram meter per second square, and then we have this is per kilogram square. So 1 kilograms and 1 kilograms will cancel. Meter per second square will cancel. So then we have what? Mass of the S is equal to 9.8, then 6.4 exponent 6. Then this is a square divided by 6.673. If you put 3, you leave 3, it is fine. Negative 11, but we have what? A kilogram. Fantastic now. You see the units of kilograms mean that it is 1 over kilogram. So 1 over kilograms, then to mean that if you find 1 over kilograms, if you take 1 divided by 1 over kilograms, then it will become 1 times kilograms of 1, which is equal to kilogram. So then now you can use your scientific calculator, okay, to determine the value of what? Value of mass of the S. So you have to use your scientific calculator like this, so don't worry, right? That the functions of scientific calculator. We don't use our brains, or maybe for example thinking that, or using the rough paper to find that computation. Okay, so you multiply by 9.8, then you divide by 6.67 exponent negative 11, then we find that it is 6.018 exponent exponent 24. But remember that I told that this will be 1, or it will be divided by 1 over kilogram. So mass of the S in this is 4 significant figure, but 3 decimal places, is 60.018 exponent 24 kilogram. It's a very huge mass. It's a very huge mass. So you know that mass of the S, in physics we do estimation. So you can estimate now, instead of writing this, we can say mass of the S is 60 exponent 24. Then what? Kilogram. Right? So that's the mass of the S. So I taught you how to write a formula to determine the mass of the S by using Newton's gravitational law. And also I taught you how to find the mass of the S. That is good. So therefore now, this is constant now, becoming, it should be kept in your mind that the mass of the S, right, the mass of the S is 6 exponent 24 kilogram. Right? Then we go to answer another question or another application. The second application, in Newton's universal gravitational law, it can be used to determine or to derive the formula and use it, the formula of 40, formula of determining what? Determining the density of what? Density of the S. So we can determine the density, not only the mass. We can determine now, we can use the Newton's universal gravitational law to determine the density of the S. Fantastic. Do you remember the concept of density? When did you meet with it for the first time? When you are in Form 1. Right? So when you are in Form 1, you met with the concepts of what? Of density. So how do we derive this concept? Okay? So the way that we derive is just we say that we will be following. The question is derive the formula of determining the density of the S. Density of the S, and use it to determine it. Right? So solution, we say that the first step we have to recall the fundamental formula. First step we say that we call the fundamental formula. We call the fundamental formula of what? Of density. Okay? In Form 1. Because we learned density in Form 1 for the first time. The topic that known as what? Density and relative densities. I like that topic, however, it was a very challenging when I was in Form 1. It challenged me a lot. Okay? So then the formula was saying that density of the substance or of the body, density of the body, of any body, right? This is equal to the ratio of mass of the body, of the substance, right? Divided by volume of 40 of the body. Right? So this is the general formula of 40 density of any body. Okay, so regardless that you are in A-level studies, don't think that you will throw the concept that we taught you in O-level. No. You have to remember them. So from that formula now, we say that density of the S, right? Density of the S should be the ratio of mass of what? Mass of Earth. Right? Which in this case, we notate like this one. Of 40, volume of 40 of the S. So we can call it VE. Okay? Thank you. You enjoy? I like physics. How about you? Think, take a second to think that how can you find the density or the relative formula of the density of the S, right? So after your thought, let us proceed. So density of the S. Say density of the S, okay? Density of the S, which you can notate it just like this, okay? This one, I said it is mass of 40 of the S, of 40 volume of the S. Okay, so then simply you can say that density of the S is equal to mass of the S over volume of the S, and this can call it the first equation. The second step, we say that consider the S as what? As sphere. And we have introduced you in the Form 3 mathematical topic called the sphere, right? The shape of the S is not circular, it is what? A sphere. So again, we taught you in different mathematical topics, especially that areas and what and perimeter, that the volume of the sphere is given as is given as 4 over 3 pi r cubic. Do you remember that? So then volume of the S right now, our body of our sphere is the S, volume of the S, and these volumes of the S, just to label VE, is equal to 4/3 pi r, radius of the S cubic, right? So then volume of the S